started. This is a bigger auditorium, so everybody feel free to spread out and get comfortable. I think it's going to be a very entertaining presentation tonight. But before we get into the presentation, I just wanted to say a couple words to get everybody's brain in the right mode, just to fully get the effect of what's about to go across here. And I just want to start it by asking you this question about value, because we're doing these life cycle assessments, but they're all based out of this question of what is value. So the Nokia dictionary on my friend's E71 phone says, value is to regard as good or important, something that has worth, importance, or usefulness. But the question I think that follows is that how is value created? Because when we talk about sustainability, we usually say environmental, economic, and social value, sustainability and the values in each one of these areas. But what do you value in each one of these categories? And also, more importantly, maybe how is value created in each one of these categories? So economic value, environmental value, and social value. And if we can create value, if we can all agree that we can create value, how do you know that what you value is actually being created? How are you assured that if you value something in the environment, that there is actually a service that's adding a value to that environmental value that you have? And also, how are those values being maintained? And in turn, how do you know when those values are being destroyed? So the systems that we use, I think, in each one of these areas, it's a bit of an interesting conversation that we're going to get into today. But the one that's interesting to me is, with regards to the economy, we know when there's economic value created because there's benefits and costs that we can quantify with dollars, and then we can say, okay, well, this is the value of this. But can we apply those same value, that same sort of a system of quantification to the environment and social values? And I hope that as a result of today, we can say a resounding yes. However, the idea of assessing value in each one of those areas is quite new. So we've got a bunch of pioneers in the audience. Today, we're going to show you some work that's actually never been done before. And in past years, we've had similar pioneers as well. So we've had 2 years of students investing their time in studying UBC buildings, because for the past 100 years, we've constructed about 14.5 million square feet of UBC, but we don't know about any of the externalities that were created as a result of creating these buildings. So we're enjoying the benefit of learning at the expense of somebody else's values that we are just totally not aware of at all. So the previous 2 years, so graciously and sacrificed a lot of time to develop this UBC LCA database. So we have 51% of the student residences at UBC modeled. We also have 52% of the academic buildings at UBC modeled. And what you're looking at here is how there's values that are being we're affecting values through the construction of buildings, and that's what you're looking at here. We won't get into it because it's a presentation to come, but this is a really interesting slide that's going to come up later on as well. But this is how we're looking at the impact on value as a result of creating social benefits through the creation of academic structures. And as a result of this UBC LCA database construction, we now have the foundation that over the next 100 years we could say, we got a hold of our externalities and we started to reduce them because we created performance measures that measured the impacts of our decision making. So over the next 100 years, we reduced our environmental impact because we were suddenly able to account for the externalities that were being created as a result of our decisions with regards to building at UBC. So this year, I was wondering how we're going to top the biggest, North America's largest building LCA database, because that's what the students have built over the previous 2 years. And then, of course, we end up with this Olympic Games in Vancouver. And I heard about this thing called the Vancouver Olympic Games Impact Study. And then I also heard that it was mandated by the Olympic Committee. They mandated this Olympic Games Impact Study, which got me really excited because then I also heard that they didn't have the venue portion of the whole study covered, and there was some consideration as to whether or not it would be included at all. So I got a hold of Rob Van Weinsberg, who's in the audience today, and pitched them the idea of having the students do it, because we studied UBC buildings. We built the North America's largest building LCA database, but maybe North America wasn't big enough. Maybe we needed to look somewhere beyond, and the Olympics are going to travel around from here on, all around the world, and this study has the potential to carry on with that, and these students have the real potential to not only impact the world in terms of, you know, everybody's watching the Olympics and everybody's getting more concerned about sustainability, but also in terms of temporal effects. So this is now history being made, and so it's actually going to travel through time. So without further ado, I just want to leave you with the progression of posters. So this is the first year poster for the same course, the final poster that we had. It was a bit conservative, so last year we decided to up it. We thought that since it's North America's largest building LCA database, we got to make it a little more shocking. So here we're talking about how life cycle assessment is changing the face of green building. And this year I thought, okay, we got to go even bigger. This time we're opening a bunch of eyes in green building, and it's got to be a little more crazy. So without further ado, I just want to bring the students up. Kenny's going to start it off. And thank you all for coming. I really appreciate everybody being here. And let's go on with the show. There's a stick at the front here.
Hello everyone, my name is Kenny, and I'm here on behalf of my classmates. I'm just going to cover the introduction, but I'm sure I speak on behalf of all of them when I say we're really excited to have you here and to tell you a little bit about what we've accomplished over the last term. So here's an overview of what we'd like to cover today. We'll start with the introduction, and we'll cover what is an LCA, how can an LCA help you, and we'll talk about the goal and scope of the study that we performed. Next, we'll look into the tools and methodology, and as you can imagine, this involved a lot of software use. We'll go from there to talk about the results. What were the impacts we found? How sensitive were those impacts? And then we'll look at some of the sources of uncertainty present in any LCA study. Finally, to conclude, we'll wrap up by looking at some other studies that have taken place around the world, including one that will be taking place for the Olympic Games in London. And we'll give some recommendations and suggest where we'd like to see LCA go from here. So the big question is, what is LCA anyway? Life cycle assessment is defined as a technique used to analyze and assess environmental impacts associated with all the stages of a product's life cycle within a chosen system boundary. We'll explain this further with an example in just a moment. There are three key stages to any LCA. The first is the goal and scope. The goal and scope involves choosing the purpose of the study and what's included, as well as importantly, what's left out of the study. Next, we'll look at the inventory analysis, which involves counting up the materials and processes in any given product. And we'll look further into the impact assessment then, which is determining the corresponding impact and impact on the environment. As I mentioned, you'll be hearing more about these from my colleagues a little later on. Each stage in any LCA requires interpretation and assumptions. As with any science, LCA creates a model and then does its best to make this model fit reality. It's important to note that LCA is not costing. Maybe you've heard it used this way in the past, but LCA that we're talking about makes measurements in terms of environmental impacts only. Every product's life cycle is created by the connections between processes. Perhaps it's best to illustrate LCA with an example. You can imagine a beer can. There are many processes which must connect together in order to create the finished product and ultimately deal with the waste. The hops must be harvested, next the beer is brewed, the can is constructed in a factory, there's delivery involved, and then ultimately the beer is consumed and hopefully the can is recycled. Those are all various processes. Every process that I just mentioned has inputs and outputs, and each one of those inputs and outputs has impacts which can be associated to it. You can imagine that transportation might cause the creation of some CO2 and that contributes to global warming. Or maybe coal is burned to provide energy for a factory, contributing to smog in the environment. All of the impacts from above, or any product that you can see around you, use in a typical day, can be grouped into environmental impact categories. Although LCA is not concerned with monetary costs, as we mentioned, you can almost think of it as environmental accounting, as in how much CO2 will it cost me to make this concrete column? Or how much smog will I create by creating a steel roof? over the last decade, I'm sure you're all well aware that